So I just want to touch on how we lay off horizontal baluster layout. I'll put a screenshot of the formula we use on the next video. We got that from, or I got that from Fine Home Building magazine, so it's just a screenshot from the magazine, but it's been a great and valuable spacing layout. So what we do is we take the width from the wall to the newel post, and then we add one baluster width, which gives us letter A. Our balusters in this application are 1/2 inch iron balusters. So we have the overall width plus 1/2 inch, which gives us 41 3/4. Next is B. That's what they're gonna do is we're gonna find the space between the balusters, which is max 4 inches per code. And then we're gonna add one baluster width, which gives us 4.5. Now, if you are looking for a different pattern where you want the spacing to be smaller than that, you can certainly use that formula or that number. Say you want 2 inches in between, you say 2 inches plus one baluster width, and that gives you this B number. Picking up there, we're gonna take our A, which was 41 3/4, and we have B, 4.5, so 41 3/4 divided by 4.5 gives us 9.278. That number is always rounded up to the next whole number. This represents the number of spaces needed to complete the horizontal run. So the spaces is 10. That is not the baluster count, but the actual spacing. And from there, you're gonna take the original A, which was 41 3/4, and you're gonna divide that by the number of spaces you come up with, which is 10 in this case. That gives you 4.175. That is the dimension center point to center point of every baluster along this horizontal run. And also take note that the very first baluster location is to the center point minus 1/2 of whatever baluster width you have. So we have 1/2 inch baluster, so it's this number minus 1/4 inch for this application. And I've used blocks before to cut this dimension and then put it on here, mark it, flip it, mark it, flip it, mark it, and keep going down the road. But every time I've ever done that, human error takes hold and everything starts to shift down. And if you think about having a 1/16 of an inch added to every one of these, that shifts you down considerably by the time you get to the end. So what I started doing was using a calculator equation to find whatever this spacing is, and then find out the sequential numbers for that. And all you do is you hit, punch in 4.175 on your calculator, and then you hit the plus button, and then hit equals. And every time you hit equals, it will add itself to itself, which gives you the location of every one of these baluster center points. Now, I don't do very well with the decimal point, so I shift it to a fraction as closest to the fraction as I can get it without dialing in more than, a 1/16. So this gives me my actual baluster layoff. So if I start on the left, after locating my first baluster minus 1/2 of the baluster width, so after that one is located, from there on, it's this number, this number, this number, this number, this number. And by doing that, it eliminates human error with shifting of a little template block. So the first one is, say, 4 3/16, 8 3/8. After the first one, 4 3/16, 8 3/8, and so on and so forth. And what this will do is give you, if you do the math right, the spacing here should match the exact same spacing that you come up with down there. And if you didn't, then you did your math wrong or you shifted a little bit. And then you can shift the whole thing a little bit left to right if you're off. Nobody's gonna ever notice a slight margin of error between this one and that one on that end. But this provides absolute equal spacing between the balusters and the newel post at the end, and it's the same every single time.